DHCP, Dynamic Host Configuration Protocol. When you walk into a coffee shop and connect to Wi-Fi, you don't have to manually type in network settings. DHCP does it for you. It is the Network Management Protocol. A DHCP server holds a pool of IP addresses and automatically leases one to your device the moment you join the network. Without this, you would have to manually configure every single device you own just to get online. Internet Protocol. Once DHCP does its job, you have an IP. This is the fundamental addressing system of the internet. Just like a house needs a street address to receive mail, every computer needs an IP address to receive data. It allows networks to route information across the globe, ensuring that a packet of data meant for your laptop doesn't end up on your smartphone. ARP, Address Resolution Protocol. But an IP address is virtual. Your router eventually needs to find your physical hardware. That is ARP. It bridges the gap between the software address, IP, and the hardware address, MAC address. When a packet arrives, ARP shouts to the local network, "Who has this IP address?" Your device replies with its physical ID, allowing the data to make that final hop to your screen. TCP, Transmission Control Protocol. Now we need to move data. TCP is the protocol of reliability. It is connection-oriented. Before sending data, it establishes a handshake with the receiver. It breaks data into numbered packets and tracks them. If a packet gets lost in transit, TCP detects the gap and resends it. It guarantees that the file you receive is identical to the one sent. UDP, User Datagram Protocol. UDP is the opposite. It is connectionless. It prioritizes speed over accuracy. It shoots data packets at the receiver like a fire hose without checking if they arrived. There is no handshake and no error correction. This is used for live streaming, voice calls, and gaming, situations where a split-second lag is worse than a slightly pixelated image. DNS, Domain Name System. Now let's browse the web. You remember names like Google.com, but computers only know IP numbers. DNS is the Internet's directory. When you type a URL, your computer asks a DNS server to translate that text into the specific numeric IP address of the website's server, allowing your browser to locate it. HTTP, Hypertext Transfer Protocol. Once the server is found, your browser uses HTTP to request the web page. This is a request-response protocol. Your browser sends a message saying "get page," and the server responds by sending the HTML code that builds the site. However, standard HTTP sends this text in the open, meaning anyone intercepting the wire can read exactly what you are typing. That is why we have HTTPS. The S stands for secure. It functions exactly like HTTP, but it wraps the entire conversation in a layer of encryption, usually TLS. Even if a hacker intercepts the data stream between you and the bank, all they will see is scrambled, unreadable code.